Will you watch when you're going, you old goat? I'm sorry, Uncle Marco. I tripped over you.
Hello, everybody. How you doing today? Well, on this EICO 147A signal tracer, I'm going to be removing this jack here and putting the BNC on it. And I'm going to remove this pin jack here and be putting the BNC on this. Not here, that's the pilot light. This. This jack here, as you probably know, those of you who own such an instrument, is the audio input, low-level input. In other words, it's on the second stage, not the first stage. So it also has high voltage on it when you put it into the noise position right here. So I'm going to put a BNC here, and I have to drill this out, and then I'm going to put a BNC here. So this will be the high level input, and also for the signal tracer probe, which I'll make up at a later date. I just want to get these taken care of now. On the back, yes, I'm hand holding this, but I'm not shaking all over the place. Hi, Doug. I gotta pick on you. If I couldn't pick on you, who could I pick on? Anyhow, this is a shielded wire right here. This wire here for the low level, this yellow one here, is not shielded, so I'm not going to worry about that. I'm just going to connect the center pin of the BNC connector, right to this wire. I'm not going to change it. But here it's a shielded wire, and that's going to take a little doing to get in there and pick up the shield off of this. Now, in order to remove these types of jacks, they got like a washer that slides down and digs into the plastic. You actually have to take a pair of pliers and snap these things off. And then you pull them out, and then I'll have to drill it out and put in a BNC. So I've got the perfect drill bits for this job. I'm going to take this outside on a bench. It's about 65 degrees out. Beautiful day. And if it doesn't rain, we're going to try to get this hole drilled out a little larger to fit a BNC. This one is a perfect size. A BNC would just go right in there. On the EICO 324, I'm not doing that today. Now, years ago, when I had my other workshop in the attic in New London, I had put a BNC connector about 2 inches above this one in this position here. So we're right next to the attenuator. And I ran a 5 picofarad capacitor at RF frequencies. That should be good. You don't need anything much bigger than that. From the center pin of the BNC to the unattenuated side of the coarse attenuator. So in other words, no matter where this position of this switch is, you've got the full output of the signal generator coming out of this jack. And they're isolated because of the 5 picofarad capacitor. I had asked a question about whether a buffer is needed, and it is not really needed, I guess. Doug told me you really don't need to. And I don't think so either, but I had asked the question on another website, but I did not get a response. So anyways, I'm not going to worry about that. When that time comes, we'll do a separate video on it. But right now, we're concentrating on the EICO 147A signal tracer at this time, and we'll do one piece of equipment at a time. Not going to bother unsoldering this. It's more hassle than it's worth. There's enough wire here. We'll just clip that off. That's the yellow wire. We'll just back that out of the way. And we're going to break this off. Now you can't really get it out any other way. You have to destroy it, unfortunately. All right, see what this little collar that's in there? See how that is? They're pressed on. So we break that right off, and now we're left with a hole in the panel right here, but the hole is a little too small for a BNC, so we're going to have to drill that out with my step drill bit, and I'll show you that in a minute here. Before we do that, well, actually, I don't need to. I can do that now because this hole don't have to be drilled. So we're going to take this outside, and we're going to remount this hole, and we'll bring a BNC connector over to the outside workbench. I want to get this going before we lose daylight here. What I am using here is what they call a unibit. These were thrown out at work when I was working. They threw them out because at the very end they would drill stainless steel, and it was pretty hard. So some of these very beginning, the first part of these tips here were actually burnt. And so what they do is they toss the whole thing right out. And of course, when I was working, I was in janitorial. So I got to clean out the maintenance shop trash, and these things were in the garbage. So I took them, and they're very, very handy to remount a hole. Now here's the BNC. These BNCs I got from eBay. I got 20 of them for less than $5. And there's a ground and a lock washer. So what I got to do is to remount the hole to accept the threaded part right here. And I hope I'm in camera. I'm looking at the viewfinder, but I'm not in focus with my eyes. And it won't, right now it won't fit in there. So we're going to get to it. So if I can get you a little closer. So what we're going to do is we'll check which unibit that would work. I think this unibit here, this is the narrower of the set. And these are American made. These aren't these Chinese Harbor Freight junk, which when it comes to tools like this, you want American made. But this is aluminum, so even if it was Harbor Freight, it would still work. But these are what they call unibits. And I've used them on this equipment before. So we're going to remount the hole, and we got to be very, very careful that we don't go too much. So I got to get my reading glasses on and get the drill set up, and we'll get started very shortly here. Okay, and make sure we're recording. Alright, here we go. Alright, we got to look carefully now, and we just plunge down one level at a time. Better to go slow than to go too far. You make the hole too big, you're SOL. You know what SOL means, don't you? Okay, we just dropped down another level, a little next level up, I should say. And not quite. Gotta make sure that the aluminum is all out of here, the shavings. No, I didn't quite get down far enough. Okay. I'm pretty sure that's the final. Yep. Alright, so that's what she's going to be like that. So if you turn it sideways here, you could probably see it a little better. Alright. Okay, I'm going to take it inside on the bench now and finish up with the mounting and the electrical part of it. Now, here is the ground lug, and because this is mounted right to the frame, the front, I will not need to connect the ground wire on that because there is no ground wire coming up from here. There is a ground wire coming up off of the Amphenol connector down below here, which goes up to this other one here, the black one, which is a pin jack, which is going to be left there. That's grounded, but there isn't any need for me to ground this twice because it's already going to be grounded when I bolt it to the case, the front. What we are going to do now is to put the lock washer on. I'm trying to work and not hit the camera here. And we put the ground on there, but we're not going to connect it. We'll just let it stay down there. We put the nut on it. It's hard for me to work with small stuff. If I have to, I'm on an angle trying to give you a good view of it. Okay, there she goes. Okay, now we got a socket wrench, and let's see if I can do this without obstructing the camera view here. This is Chinese steel, so we don't want to strip it out. Okay, she's on there pretty snug. And let me just check something here. Be nice if this was faced the other way. Let me turn this around so that the where I'm going to solder will be faced out this way, so I can see to put the wire on. Oh, hang on, we're going to do that off camera here. I'm not going to connect this up right now. I moved it so that there's like a little area where it's like a well and I can stick the wire in there, but I'm not soldering this back on right now until after I remove this here and put the BNC in its place. So what we got to do is heat up the soldering iron and remove, heat up the center pin of this Amphenol connector here so I can pull the wire out. I'm not sure if the shield is on it or not, but we're going to give that a try and see. So we'll come back in a minute here. I'm going to be doing this off camera here because I'm going to be in the way of the camera when I'm trying to do it. So we'll come back on the video once I get the wires off of this Amphenol connector right here. Alright, as you can see, that was very easy. The shield I thought might be connected somehow inside the Amphenol connector on the rim, but it wasn't. Only the center conductor came through the Amphenol connector. So the shield is only grounded at the opposite end of the cable. It is not grounded at this end, which makes it easy. So all I got to do is to just bring this up to the BNC. I had to use a pair of pliers. I'd have to dig in the big shed there and try to get the socket to go in here. I didn't have a socket that'll fit on this. The angle is hard because of the electrolytic capacitor right here. So I needed a box wrench or an end wrench, and I didn't have one big enough in the electronic shed here because I don't have the big tools in here. I only have a small set that only goes up to 1/2 inch. Now this is your Amphenol connector, so we won't throw that away because there's nothing wrong with it. You see the grounding ring that's sitting here, okay? We can use that same grounding ring for the BNC that's going to be going in there. So we're going to get a BNC connector right now out of the container of BNC connectors that I got off of eBay. And we're going to take off the the nut, and we lower to take the lock washer off, and put the BNC connector right in. Now it fits a little loose, all right, but nothing to worry about. So we take this ground ring here and put that right down there, and we put the lock washer on top, and getting the nut started. We're a little bit breezy out there. You might be able to hear the wind. I got the shed door open here. I can't get the damn nut started. There it goes. All right, now we got to make sure that I got to get my eyelope out here and make sure that the okay, make sure that that's faced that way so I can get my wire in there. And then we've got the, I just want to make sure I'm still recording, and we got to put the nut, tighten the nut up. Now, I can get this in there all right, but I couldn't do much with the other. And I can't get that tight. What I got to do, it's rolling on my fingers. So there's a trick to doing that. You take a BNC, put a BNC plug on it, and that'll hold it while I lock it up. Okay, beautiful. All right, so this is the finished product on the outside, and we just eliminated the ring because we've already got a grounding ring on it. We're just going to go like this right onto the jack, and we may shorten this center conductor up a little bit and solder it right in there. On the other hand, I don't think I'm going to worry about it. And this one is not shielded. This is the way it came. It looks like it might be a little too short, so that's not a problem. That wire goes down here on this switch right there, the yellow. That's for the low level audio input, which also puts out a high voltage when you're doing your component noise test. I'll just take and change that wire out. That's all. So I'll come back on this video in a little bit here. While my soldering iron is getting heated up here, I trimmed back this coaxial. It was too long, so I cut back because the center conductor was very long, and it had a cut in it down to the conductor. And so I stripped it back a little bit so there was insulation right here. So I'm going to solder this in. Now, I'm not sure how these BNC connectors are. If it's Teflon, it won't melt. If that's white plastic, it could melt, so we've got to be very careful with heating this. I'm going to do this off camera because I really need to get right in here close, and I really need to pay attention here. So I'm going to try to get this tinned and this tinned and then just put them together. Okay, I hope you can see that through the magnifier here. I think it came out pretty good. We just tacked it very quickly on there. We got a nice shiny solder connection. You have to be careful with this coaxial. If you heat up the center conductor too much, it's going to melt the dielectric around it, and then it's going to be shorted to the shield, and we don't want that. So that concludes that one. Now we're going to take care of this. Again, we're going to do this off camera. We're going to change this wire out because this wire, I'm going to have to stretch it for all it's worth here, and there is just no leeway. So I'm going to do this off camera, and I'll come back when I get this job done. I got it in. It's a dull solder connection, but very, very difficult for me to see in there. I didn't have yellow wire, so I had a piece of white. I didn't want to use red, and I didn't want to use black. So white is going to be it. So now we're going to flip this over, trim this down, tin the end, and put it into the BNC up in the top end there. Well, it ain't like the jobs I used to do when I was younger. A crappy soldering job, but I just can't see. I have to hold the eye lope. I have to carry the solder over on the iron and put it on the work, which is the wrong way to solder. But I have to hold it on and then do it that way, because I just can't see what I'm doing. So that's why I'm called a blind tinkerer. All right, so we turn on the unit. Like I say, this switch only goes on or off, that's all. The other functions no longer work. I've got a Chinese special here that I've got off of eBay, BNC 2-clip lead. So first of all, we'll connect it to the audio input. Now, okay, we'll ground it. Okay. We got the gain all the way up, so the shielding is good. There's no hum, and I'm on a high level input right now. Okay? Oh. See, when you disconnect it, it really, because, you know, we're picking up stray fields here right now. All right, now let's go into the top one, which is the low level. Just a minute. I'm wrong there. Okay. I had it set on RF, so that jack just was wide open. Okay, this is the RF. This is the low level. Okay? Now, if I put it over to here, this is your noise test, so you don't want to touch these leads now because you got about 185 volts on it or thereabouts. But it's limited with current. The instructions tell you that it's not going to hurt you too much, but you don't really want to get a shock off of it. So we turn the gain down. So let's check the voltage coming out of this, because this jack will only be used for noise or low-level audio. As long as I don't put this switch into the noise position, I won't have to worry about getting shocked off of this. So I can still use this as a component tester like noisy resistors and so forth using this jack. So let's put a meter on this thing and see what we've got here. Hang on a minute. Okay, I've got the volume control covered a little bit. So I got it turned all the way down because the meter's in the way. Right now it's on audio. So in other words, you're not going to hear anything now because I got the volume all the way down. I want to show you what voltage we're going to be getting out of this. So we're going to be connecting up the leads here. Right now you shouldn't be getting any voltage out of it. Just millivolts, it's just random. Okay, now if I was to switch this over to noise now, remember we're plugged into this red jack, what used to be the red jack that I put in the BNC on. This is the noise position here, so which is what we're on right now. We got 185.2 volts on this. And it's low current. See, I'm shorting it out. See, but all that is noise. It checks for noise. I'll put this volume up. If we had a resistor to put across this, and if the resistor was noisy, you would hear it in the audio. So it's a good feature to have. Now if we turn this down to audio, I think it's meter off of here. If we turn this down to audio, of course we got these leads picking up. This is low-level audio, but if I short it out, see, there's nothing. It's just picking it up because, you know, these leads here are like 5-6 inches long, and they're not shielded at this point to the clips. All right, so this is like the second stage. Now when we move this down to the first stage, which is marked RF input, this is where your signal tracer probe with the diode would go into. By the same token, if you want to check for very weak audio signals, that is a very good thing to use, and you just flip it over to the RF, and we'll get this meter out of the way here. It is very, very sensitive. Let me get this meter out of the way here. You don't really need it up here now. I just want to show you that we are getting the high voltage out of this when this is plugged into here and when this is set to noise. So right now you've got a very high gain amplifier. But if you short this out, see, it's quiet. When you take the clip off, you just get a little stray out of here because, you know, we're not shorted out. But you don't usually, when you're not using it, you're not going to turn the gain all the way up. But I just proved the fact that you can put the cord in here and short this out. These clips are very hard. They the rubber on the outside keeps slipping and the clip inside keeps turning. They're very awkward to use. Now you put this on, see, she shorted out, put the gain all the way up, dead silence, see? So it's a very sensitive audio amplifier. Another thing I did on this unit, we'll turn this off, take this off. I want to show you something here. All right, I wired this cord in here, kind of a Mickey Mouse thing. It's a 2-prong polarized plug. I wanted a 3-prong and I wanted to ground the chassis, but I didn't have a 3-prong, and I wasn't going to use one of them computer cords. I don't like the way the color codes are on them, and the wire is too thin. Although on this it wouldn't really matter. I was going to put a, in fact I did. I was going to put well, I've got X caps that I have got from Sal's Computer Corner. And I'll show you. I've got a bunch of them. They're all X caps. There's no Y caps. So no matter how much magnification I use, I cannot read these. So I have to go by the package. So this originally called for, I think, a .022 to ground. It had a ceramic disc in it from the hot side to the chassis. And as I showed you in one of my other videos, I can feel a hot chassis on this. It's what they call phantom voltage, and I discussed that before. It had a disc capacitor like this one down here, and you probably can't see it. I got to move the camera down here. I'm trying not to move. I want to practice what I preach about tripods. If I don't move the camera too much, I do not use a tripod. But if I'm moving around and I'm doing this stuff here, you're going to get sick, and I don't want my viewers sick. So like I'm doing now, I'm holding the camera fairly steady. I was getting a hot chassis, 113 volts, but that's high impedance meter. It's phantom voltage. Really, there's no hazardous voltage there. There is no need for a bypass capacitor on this unit. There is no need for a capacitor, bypass capacitor, from hot side to ground on the EICO 950. They do not need it. Now maybe a signal generator does. This one was rebuilt by Don, and he's the one that gave me that signal generator. That already has that capacitor in there. But each time you add these capacitors, you get a hot chassis. Not a dangerous one, but capacitors pass AC, so you do get a little tingle. Nothing major, but you can feel it very, very, very slightly, especially if you got wet fingers. So what I had done is, instead of using an 022, I use a 0047, and I still got a hot chassis, so I removed it. It no longer has a bypass capacitor to chassis from hot side. It doesn't need it. If this was a radio, yes, you definitely need it. A signal generator, yes, you need it. You do not need it on these types of equipment. You probably would need it on a frequency counter because it could be subject to line interference. What line interference are you going to possibly get here that can influence it? None. It's going to make the eye to jiggle a little bit, you know? No, it's not going to do anything. So you don't need it. That's my opinion. And it's my story, and I'm going to stick to it. Thanks for watching, guys and gals. I appreciate everybody watching. So that concludes the modification for this signal signal tracer. And if you watch my earlier video on this, I got rid of this switch because it would not work in the wattage section. The power would not come on. The switch was defective. I could not repair it. So the watt function of this does not work. I don't care about that. It was not accurate anyways, no matter what I did. Don't need it. So now the next project, not necessarily the very next project, because I still got to make the dim bulb setup, will be the EICO 324. Thanks for watching. That concludes this project.